6. Physical and chemical changes. Every day, you come across many changes in your surroundings. These changes may involve one or more substances. For example, your mother may ask you to dissolve sugar in water to make a cold drink. Making a sugar solution is a change. Similarly, setting curd from milk is a change. Sometimes milk becomes sour. Souring of milk is a change. A stretched rubber band also represents a change. Make a list of 10 changes you have noticed around you. In this chapter, we shall perform some activities and study the nature of these changes. Broadly, these changes are of two kinds, physical and chemical. Figure paper pieces. 6.1 Physical changes. Activity 6.1. Do this. Cut a piece of paper in 4 square pieces. Cut each square pieces further into 4 square pieces. Lay these pieces on the floor or a table so that the pieces acquire the shape of the original piece of paper. Figure. Obviously, you cannot join the pieces back to make the original piece. But is there a change in the property of the paper? Activity 6.2. Do this. Collect the chalk dust lying on the floor near the chalkboard in your classroom, or crush a small piece of chalk into dust. Add a little water to the dust to make a paste. Into, Roll it into the shape of a piece of chalk. Let it dry. Did you recover chalk from the dust? Activity 6.3. Do this. Take some ice in a glass or plastic tumbler. Melt a small portion of ice by placing the tumbler in the sun. You have now a mixture of ice and water. Now place the tumbler in a freezing mixture, ice plus common salt. Does the water become solid ice once again? Activity 6.4. Boil some water in a container. Do you see the steam rising from the surface of water? Hold an inverted pan by its handle over the steam at some distance from the boiling water. Observe the inner surface of the pan. Do you see any droplet of water there? Activity 6.5. Do this. Caution. Be careful while handling a flame. Hold a used hacksaw blade with a pair of tongs. Keep the tip of the free end of the blade on the gas stove. Wait for a few minutes. Does the color of the tip of the blade change? Remove the blade from the flame. Observe the tip once again after some time. Does it get back its original color? In activities 6.1 and 6.2 above, you saw that paper and a piece of chalk underwent changes in size. In activities and water change its state from solid to liquid or from gas to liquid. In activity, the hacksaw blade changed color on heating. Properties such as shape, size, color and state of a substance are called its physical properties. A change in which a substance undergoes a change in its physical properties is called a physical change. A physical change is generally reversible. In such a change, no new substance is formed. Let us now consider the other kind of change. 6.2 Chemical change. A change with which you are quite familiar is the rusting of iron. If you leave a piece of iron in the open for some time, it acquires a film of brownish substance. The substance is called rust and the process is called rusting. Figure. Iron gates of parks or farmlands, iron benches kept in lawns and gardens. Almost every article of iron kept in the open gets rusted. At home, you must have seen shovels and spades getting rusted when exposed to the figure rusting iron. Atmosphere for some time. In the kitchen, a wet iron pan tawa often gets rusted if left in that state for some time. Rust is not iron. It is different from iron on which it gets deposited. Let us consider a few more changes where new substances are formed. Activity 6.6. Do this. To be demonstrated by the teacher. Caution. It is dangerous to look for long at the burning magnesium ribbon. The teacher should advise children not to stare at the burning ribbon. Get a small piece of a thin strip or ribbon of magnesium. Clean its tip with sandpaper. Bring the tip near a candle flame. It burns with a brilliant white. Figure magnesium ribbon burning. Light figure. When it is completely burnt, it leaves behind a powdery ash. Does the ash look like the magnesium ribbon? The change can be represented by the following equation. Magnesium Mg or oxygen O2, magnesium oxide MgO. The equations here are different from those in mathematics. In equations of this kind, the arrow implies becomes. No attempt should be made to balance chemical equations at this stage. Collect the ash and mix it with a small amount of water. Stir the mixture aqueous solution well. Test the mixture with blue and red litmus paper. Does the mixture turn red litmus blue? Does the mixture turn blue litmus red? On the basis of this test, how do you classify the aqueous solution acidic or basic? On dissolving the ash in water, it forms a new substance. This change can be written in the form of the following equation. Magnesium oxide MgO plus water H2O becomes magnesium hydroxide MgOH whole 2. As you have already learnt in chapter, magnesium hydroxide is a base, so magnesium oxide is a new substance formed on burning of magnesium. Magnesium hydroxide is another new substance formed by mixing magnesium oxide with water. Activity 6.7. Do this. To be demonstrated by the teacher. Dissolve about a teaspoonful of copper sulfate, blue vitriol or Nila thota in about half a cup of water in a glass tumbler or a beaker and add a few drops of dilute sulfuric acid to the solution. You should get a blue colored solution. Save a small sample of the solution in a test tube or a small glass bottle. Drop a nail or a used shaving blade into the remaining solution. Wait for half an hour or so. Observe the color of the solution. Compare it with the color of the sample solution saved separately. Figure. Copper sulfate blue, iron sulfate greenish. Figure. Change in color of the copper sulfate solution due to reaction with iron. Color of the solution from blue to green is due to the formation of iron sulfate. A new substance, the brown deposit on the iron nail is copper. Another new substance, we can write the reaction as copper sulfate solution blue plus iron becomes iron sulfate solution green plus copper brown deposit. Activity 6.8. Do this. Take about a teaspoonful of vinegar in a test tube. Add a pinch of baking soda to it. You would hear a hissing sound and see bubbles of a gas coming out. pass this gas through freshly prepared lime water as shown in figure. What happens to the lime water? Do you see any change in the color of the solution? Take out the nail or the blade. Has it changed in any way? The changes that you notice are due to a reaction between copper sulfate and iron. The change in the test tube is as follows: vinegar, acetic acid, plus baking soda, sodium hydrogen carbonate, carbon dioxide, plus other substances. The reaction between carbon dioxide and lime water is as follows: carbon dioxide, vinegar plus baking soda, lime water. Figure set up to pass gas through lime water. Carbon dioxide CO2 plus lime water CaOH whole 2 becomes calcium carbonate CaCO3 plus water H2O. When carbon dioxide is passed through lime water, calcium carbonate is formed, which makes lime water milky. The turning of lime water into milky is a standard test of carbon dioxide. You will use it in chapter to show that the air we breathe out is rich in carbon dioxide. In activities, you saw that in each change, one or more new substances were formed. In activity, the ash was the new substance formed when magnesium was burned in air. In activity, the reaction of copper sulfate with iron produced iron sulfate and copper. Both of these are new substances. Copper was deposited on the shaving blade of iron. In activity, vinegar and baking soda together produced carbon dioxide, which turned lime water milky. Can you name the new substance formed in this reaction? A change in which one or more new substances are formed is called a chemical change. A chemical change is also called a chemical reaction. Chemical changes are very important in our lives. All new substances are formed as a result of chemical changes. For example, digestion of food in our body, ripening of fruits, fermentation of grapes, etc. happen due to a series of chemical changes. A medicine is the end product of a chain of chemical reactions. Useful new materials such as plastics and detergents are produced by chemical reactions. Indeed, every new material is discovered by studying chemical changes. We have seen that one or more new substances are produced in a chemical change. In addition to new products, the following may accompany a chemical change: heat, light, or any other radiation, ultraviolet for example, may be given off or absorbed. Sound may be produced. A change in smell may take place or a new smell may be given off. A color change may take place. A gas may be formed. Let us look at some example. You saw that burning of magnesium ribbon is a chemical change. Burning of coal, wood or leaves is also a chemical change. In fact, burning of any substance is a chemical change. Burning is always accompanied by production of heat. Explosion of a firework is a chemical change. You know that such an explosion produces heat, light, sound and unpleasant gases that pollute the atmosphere. That is why you are advised not to play with fireworks. When food gets spoiled, it produces a foul smell. Shall we call this change a chemical change? You must have noticed that a slice of an apple acquires a brown color if it is not consumed immediately. If you have not seen this change in color, cut a fresh slice of apple and keep it away for some time. Repeat the same activity with a slice of potato or brinjal. The change of color in these cases is due to the formation of new substances. Are not these changes chemical changes? In chapter 5, you neutralized an acid with a base. Is neutralization a chemical change? A protective shield. You must have heard of the ozone layer in our atmosphere. It protects us from the harmful ultraviolet radiation which come from the sun. Ozone absorbs this radiation and breaks down to oxygen. Oxygen is different from ozone. Can we call the breaking down of ozone a chemical change? If ultraviolet radiation were not absorbed by ozone, it would reach the Earth's surface and cause harm to us and other life forms. Ozone acts as a natural shield against this radiation. We learned in chapter 1 that plants produce their food by a process called photosynthesis. Can we call photosynthesis a chemical change? Paheli said that even digestion is a chemical change. 6.3 Rusting of iron. Let us get back to rusting. This is one change that affects iron articles and slowly destroys them. Since iron is used in making bridges, ships, cars, trucks, bodies, and many other articles, the monetary loss due to rusting is huge. The process of rusting can be represented by the following equation: iron Fe plus oxygen O2 from the air plus water H2O becomes rust iron oxide Fe2O3. For rusting, the presence of both oxygen and water or water vapor is essential. In fact, if the content of moisture in air is high, which means if it is more humid, rusting becomes faster. So, how do we prevent rusting? Prevent iron articles from coming in contact with oxygen or water or both. One simple way is to apply a coat of paint or grease. In fact, this coat should be applied regularly to prevent rusting. Another way is to deposit a layer of a metal like chromium or zinc on it. Chromium or zinc on iron. Oh, that is why my friend Rita is always complaining about iron articles rusting so fast. She lives near the coast. This process of depositing a layer of zinc on iron is called galvanization. The iron pipes we use in our homes to carry water are galvanized to prevent rusting. You know that ships are made of iron and a part of them remains underwater. On the part above water also, water drops keep clinging to the ship's outer surface. Moreover, the water of the sea contains many salt. The salt water makes the process of rust formation faster. Therefore, ships suffer a lot of damage from rusting in spite of being. Stainless steel is made by mixing iron with carbon and metals like chromium, nickel, and manganese. It does not rust. Painted, so much so that a fraction of ship's iron has to be replaced every year. Can you imagine the monetary loss to the world? 6.4 Crystallization. In class 6, you have learned that salt can be obtained by the evaporation of seawater. The salt obtained in this manner is not pure and the shape of its crystals cannot be seen clearly. However, large crystals of pure substances can be formed from their solutions. The process is called crystallization. It is an example of a physical change. Activity 6.9. Do this. To be performed in the presence of the teacher. Caution. Use only dilute sulfuric acid. Be careful while boiling water. Take a cupful of water in a beaker and add a few drops of dilute sulfuric acid. Heat the water. When it starts boiling, and copper sulfate powder slowly while stirring continuously. Figure. Continue adding copper sulfate powder till no more powder can be dissolved. Filter the solution. Allow it to cool. Do not disturb the solution when it is cooling. Look at the solution after some time. Can you see the crystals of copper sulfate? If not, wait for some more time. Copper sulfate crystal. Figure. Crystals of copper sulfate. You have learnt about physical and chemical changes. Try to identify changes that you observe around you as physical or chemical changes. Keywords: chemical change, chemical reaction, crystallization, galvanization, physical change, rusting. What you have learned: changes can be of two types, physical and chemical. Physical changes are changes in the physical properties of substances. No new substances are formed in these changes. These changes may be reversible. In chemical changes, new substances are produced. Some substances can be obtained in pure state from their solution by crystallization. Exercises: do this and comment this. Extended learning activities and project. Do this and comment this. Did you know near the Qutub Minar in Delhi stands an iron pillar figure which is more than 7 meters high. It weighs more than 6,000 kg. It was built more than 1600 years ago. After such a long period, it has not rusted. For its quality of rust resistance, it has been examined by scientists from all parts of the world. It tells something about the advances India had made in metal technology as back as 1600 years ago. Figure: iron pillar.